Okay, hello folks. Mr. Gilbert here. Like I've mentioned, we're sort of moving ahead with some online lessons starting today, Monday. This may be posted on Sunday. I'm recording it here on Sunday morning. Before I get going, I am going to be posting before I post the lesson, or at the same time, I'll be posting the handouts that go with it. So if you want to find those, if you go into the Google Classroom, today's lesson is 4.1, Common Factoring. And what I've done here is I've posted a Word document and I've also posted a PDF. They're both the same, but this way you'll get whatever file you need. So if you open the Word document, you'll be able to look at it, which isn't very useful. And this is what works for me. It might not work for you. You might have to try to figure it out or get in touch with me to troubleshoot. But if I click the three dots, open a new window, I have it here, and now up here I can say open with, and I can choose Docs, or I can choose Doc Hub. Now, if you have the Doc Hub option, I recommend you give it a shot, especially because you have a touchscreen device. This might allow you to edit it. So I'm going to sign in with Google. I'm going to choose my Google account. And once I'm in here, I can actually click this pen, and I can kind of write all over it. And I'm sure if I click down here, I'll be able to do other things. I can probably change the pen color, and I can change the width to a really small pen. If I click here, I can change the color, all sorts of fun stuff. There we go. Or I can click red or whatever. So if you want to do some of these things, you're welcome to do that. I'm just going to close that because it's all messed up. So that's where the handout is, and I'll be going through the lessons much like I do in class, sort of adhering to the handout that I've given you so that it's easy to follow along. So I'm going to flip back to my file here and get started. So this is not ours. This is a different class. This one's ours. All right, so we are starting a new unit today. It's called Factoring Polynomials. It's basically quadratics part 2. So hopefully you remember these things called parabolas that we did in unit number 3. And again, I have emailed everyone with their test marks, except for those of you that didn't write that test. So the new unit's called Factoring, and we're going to start right here. So what I'm going to do is I'm going to encourage you to pause the video in a moment and try this problem on your own. So the problem is a customer orders 2 rugs, one with an area of 10 meters squared, and the other with an area of 15 meters squared. And what I would like you to do is to determine the possible dimensions for the rug that's 10 square meters and determine the possible dimensions for the rug that is 15 square meters. So to get you started, if it's 10, it could be 2 times 5, etc. So find all the different dimensions that you can. I'm going to pause my video in a second. I encourage you to pause it right now and then continue after. Okay, so if you didn't pause, the answers just sort of showed up instantly there. That's something that we'll work on. So here are the options for the 10, 2 by 5, 1 by 10, 10 by 1, 5 by 2, and for the 15 square meters, 1 by 15, 15 by 1, 3 by 5, 5 by 3. You'll notice that switching the length and the width obviously is kind of the same rug, it's just would be positioned differently, but this is the kind of thing I want you to keep in mind, that there are a few answers to some of these problems. All right, moving on. Okay, now I want to go back to a concept that you learned in elementary school, and that is to find the greatest common factor of 2 numbers. So if instead of 4 and 20, I gave you 10 and let's say 35, what's the greatest common factor of 10 and 35? What that means is what number divides evenly into 10 and also into 35. Now, obviously, 1 is always an answer, but that's not the greatest. 2 doesn't work into 35, 3 neither, 4 neither, 5 goes into both. Okay, so 5 is a common factor, and that's it. 5 is the answer. So what I would like you to do is find the greatest common factor of 4 and 20. I'd like you to pause now. Okay, so if you paused and figured it out, you probably would have found that the greatest common factor is 4, because 4 divides into 4, and 4 goes into 25 times. You may have said 2, and 2 is a common factor, but it's not the greatest common factor. So another common factor is 4. And then we're already at 4, so we can't go any greater, obviously. So the answer is 4. All right. So I want you to try these next. Let's just do these next two. So find the greatest common factor of each of those. Pause it now. Figure those out and come on back. All right. Pause now. All right. So 18 and 30. I believe the answer is 6. Goes into 18 3 times and 35 times. And for 30, you may have said 5. And if you did, you missed out on 15. So 15 goes into 30 twice, and it goes into 75 5 times. Now, if you can't do this in your head, and some of you don't have your times tables memorized, you can come in here to a calculator and do 30 divided by, let's say, 10. It works. Let's try 75 divided by 10. Doesn't work. It's a decimal number. Doesn't go in evenly. Let's try 15. 2, so it works. Let's try 75 divided by 15 is 5, so it works. And let's try 30. We know it goes into 30, obviously. Let's do 75 divided by 30. Doesn't work, so 15 is our answer. And this idea of finding common factors is going to be a huge part of today and the rest of the unit. All right, last two. Let's say one more, and then the last one. All right, try to find the greatest common factor of x and x squared. This one's a little trickier. I'm going to get you to pause now. Okay, so if you had trouble with this one, that's fine. It's a bit of a new concept today. So things that go into x, I mean, the only things that go into x are 1 and x. And 1 really is kind of a cop-out answer. It doesn't really serve any purpose, because if you divide x by 1, you get x. If you divide x squared by 1, you get x squared. So 1 doesn't really help us at all. So you may have figured out that x does, in fact, go into x, and it also goes into x squared. So x divided by x is 1, and x squared divided by x is going to leave us with x. More on that soon. This is the last one. I really, really hope you pause and try this one before we move on. And that is to find the greatest common factor of 3x squared and 6x cubed. Please pause now. All right, so if you got this one, I think you're probably almost good to go with all of today's lesson. What we're going to need to do here is we're going to break these terms up into their coefficients. That's the number that's out front, and their variable parts. So first, what's the greatest common factor of the coefficients? The greatest common factor of 3 and 6 is going to be 3. And now we're going to find the greatest common factor of x squared and x cubed. Obviously, they both have an x, so we can take out an x. But this one has x squared, or you could say 2x's multiplied together. And this one has x cubed, or 3x's multiplied together. So we can actually take out an x squared from both. Okay, so this is your greatest common factors. Remember, 2 wasn't the answer there. And we will move forward now. So at this point, I am going to be doing what's on your handout. So if you have the handout, you might want to follow along there. So we're just going to fill in these terms real quick. So to express a number as the product of 2 or more numbers, or express an algebraic expression as the product of 2 or more terms, that's a mouthful, or an earful, I suppose, and this is called factor. And that's the name of the unit. You're going to become very familiar with this process. And to break a number or an expression into parts, this is going to be decompose. And if you're not having a lot of success writing on the document, it's probably not a big deal. I'm going to post this when I'm done anyway, and it'll probably already be posted for you when you take a look. Actually, no, it won't. I'll post this part the next day because I don't want you to just use my notes. I don't think that would be as productive. But if you're having trouble, I mean, you can print it if you have a printer. I don't have a printer at home anymore. I lost my office when Elliot was born. And as for the examples over here, I will fill those out at a later date. Speaking of Elliot. Hey, buddy. Okay, so this next part isn't actually on your handout, but it's something that hopefully you remember from grade 9, and that is the distributive property. So you might remember that if you have a number outside of brackets, what you can do is multiply this through the brackets. And if you do that, you get 4 times x is 4x, and then 4 times 3 is plus 12. And that's all well and good. You should be experts at that at this point. And again, that is a grade 9 skill. So what we are going to do today, and this is called expanding, what we're going to do today is the reverse, and that is called factoring. And if you wrote the test the day before the, in quotes, March break, that has ended up being about 7 weeks long or something, you would have actually done a question kind of like this, but you would have worked backwards into the brackets. And if you got that question right, which a lot of you did, you've already done factoring. And in fact, you've already done the factoring that we're not going to do until our next lesson. So today, hopefully, will be an easy day. So expanding goes in the direction from this with brackets. We get rid of the brackets. Factoring, we go from the expanded, and we take it back into its original brackets. You can imagine this way, the factoring part is harder because you have to figure out what it was. Whereas expanding, you just multiply and the answer's there. Okay, so if we expand by multiplying, we're going to factor by dividing. And so dividing is going to be at the core of what we do today. So when we factor, the first thing we need, and this is why I did this, when we factor, the first thing we need is the GCF, or the greatest common factor. So let's take a look here. I would like you to consider this little expression here. It's got two terms, 5x squared and negative 20x. And I would like you to figure out the greatest common factor of these two terms. And you can go ahead and pause it and figure it out now. All right, so we look at the numbers first. 5 and negative 20. Because the first term is positive, I'm just going to take out a positive. More on that later. And now the variable part. We've got x squared and we've got an x. I can take an x out. Now, here is your first factoring question, and I don't expect you to do it, but I'm going to walk through it now. So if you want to try it yourself, you can pause, and you can kind of pause at any time. So when we factor this greatest common factor, it's actually going to come out front, and then we're going to put some brackets. So what you can do is pause now and figure out what goes in the brackets so that when this gets multiplied through, we get back to here. So again, feel free to pause and try that. If not, I'm going to do it now. So 5x times something gives us 5x squared. Well, I know that that's x. And 5x times something has to give us negative 20x. And that's going to be minus 4. Okay, now if that seemed like a little bit of magic, let me instead show you how to do this a bit of a different way. Once we find the greatest common factor, we divide each term by the greatest common factor. So 5x squared divided by 5x, the 5's cancel. We have an x squared divided by x. So one of the x's up here cancels. This one's gone. And we're left with a single x. And over here, we divide the numbers. Negative 20 divided by 5 is minus 4, or negative 4. The x's cancel, and we're done. You can always check a factoring question by expanding. 5x times x is going to be 5x squared. 5x times minus 4 is going to be minus 20x. And then I check the original question, and it's the same. Now, this is just a check. You're not expected to do this every time. And that's the answer. That is your first factoring question that you've ever done, unless you figured out the one on the test or Ms. Trusser gave you some last year or something. Okay, back to the handout. This is example 1. I think you can do this one already, maybe. Some of you might not be able to yet. Part B, you might be able to figure out already. This one's a little trickier, but it's the same idea. You find the greatest common factor of all three. This one is harder. You might want to wait on that one. And this one is hard as well. So I would encourage you to try A and B. So pause right now, try A and B, and then come back, and I will take you through it. So again, if you want to pause now and try A and B, please do it now. All right, so example 1A. We need to factor this. It's two terms. We've got 3x squared, and we've got negative 6x. Okay? So the first thing I'm going to do is find the greatest common factor. So I'm going to write an equal sign here, because what I write on the line below is going to be the same as this. It's just going to look different. So I look at the number part first. 3 and 6. I'm going to ignore the sign for a second. 3 and 6, obviously 3 divides into both. That's the biggest number. And let's look at the variable part. We've got x squared and we've got an x. They both have x's, so I'm going to take an x out of both. Now, if I divide 3x squared by 3x, I am left with x. And if I divide negative 6x by 3x, negative 6 divided by 3 is negative 2. X divided by x is nothing, and that's your answer. And again, you can expand that and double check that it works, but I promise it does. Wait. Yeah, I promise. Okay, next one. So again, first we find the greatest common factor of the numbers. 10 and 25, I can take a 5 out. A cubed and a squared, obviously I can take an a, but this kind of has 3 a's multiplied, and this has 2 a's multiplied, so I can actually take a squared out of both. Now I'm going to take out, in air quotes, I made air quotes with my fingers, I'm going to take 5 out of 10 by dividing though, right? Not subtracting. So 10 divided by 5 is 2. A cubed divided by a squared is just a. And the next part, negative 25 divided by 5 is negative 5. A squared divided by a squared is nothing. It cancels out. So there's your answer. Feel free to expand back through. Double check that it works. I'm pretty sure it does. Example 3, okay, or C. So the only difference this time is that we have 3 terms. And honestly, that's no different. We just now have to find the greatest common factor for all 3 at once. So first, let's look at the numbers. 9, 12, and 6, or negative 6. I can take a 3 out of them. Now I'm going to look at the x's. Then separately, I'm going to look at the y's. So I've got x4, x3, and x2. Well, I can take an x2 out because they all have at least x2. And the y's, y to the 4, y squared, y cubed, I can take out 2, or y squared. Now I divide each term separately by 3x squared, y squared. 9 divided by 3 is 3. x4 divided by x2 is going to leave us with x squared. Y to the 4 divided by y to the 2 is going to leave us with y to the 2, or y squared. 12 divided by 3 is 4. X cubed divided by x squared is x to the 1, or just x. Y squared divided by y squared, they cancel, so no y's are left. That last term, negative 6 divided by 3 is negative 2. X squared divided by x squared, they cancel. Y cubed divided by y squared is y to the 1, or just y. And again, feel free to now expand this through and make sure it works. I'm pretty sure it does. Let me check. 9 x4 y4, yes. 12 x3 y squared. Negative 6 x2 y3. Yep, it works. All right, second last one. This one looks really different because there's brackets in it already. So this time, we're going to look for the greatest common factor of these 2 big terms. And this one's actually a lot easier than it looks. I want you to take a minute and try and figure out what's the greatest common factor of 5x bracket x minus 2 bracket and negative 3 bracket x minus 2 bracket. I encourage you to pause now. All right, if you didn't figure it out, the greatest common factor, or the thing they have in common, is this x minus 2. So we're going to take the x minus 2 out of both, and then we'll see what we have left. If we take x minus 2 out of the first term, we need brackets, we're left with 5x. If we take the x minus 2 out of the second part, and I should have put the square around the minus sign as well, if we take the x minus 2 out of this, we're left with minus 3. And that's it. When you expand this, it's going to look a bit weird. It's not going to look exactly like this. But if you then go and expand this, and collect your like terms and simplify, you will find, I believe, that it is the same. Okay, last one. Last one, and I'm not as concerned about this one. This is a bit of a trickier one, but I do encourage you to do it because it leads us nicely into what comes later in the unit. So in this case, we have 4 terms. This is the first time we've seen this. Typically, we've had 2 or 3. When you have 4, what you're going to want to do is sort of pair them up. So you're going to want to pair up these two, and you're going to want to pair up these two here. Okay, so what I'm going to do, I'm going to write an equal sign. And now what I would like to do is first, what do these two terms have in common? And hopefully you quickly thought or said to yourself, A. So I'm going to take an A out of these terms. If I take an A out of AX, I'm left with X. Remember, I'm dividing. If I do negative AY divided by A, I will get minus Y. Okay, now, last one. This is the first time we've seen a negative sort of in a first term here. So they both have a 5. The first term has a negative 5. So I'm going to take out a minus 5 or a negative 5. More on that in a minute. If I take negative 5 out of negative 5x, I'm left with x. If I take negative 5 out of 5y, I'm doing 5y divided by negative 5. I get negative 1y. Now, you might think you're done, but you're not. What I encourage you to do now is look at this, consider the previous example, and see if you can finish this one. If you're going to try it without me, pause it now. All right, so I look at this. I now have two huge terms. What do they have in common? Well, they both have an x minus y. So I take an x minus y out of both. And if I take x minus y out of the first term, I'm left with a. If I take x minus y out of the second term, I'm left with minus 5. And now I am done. So this is the homework that I've assigned for this. Again, I did post the online version of the textbook. But before I do that, I want to do one last question, a bit of an exit question here. I'll do one and then I'll give you an exit question. So I want you to try to factor this, but you may want to wait and watch me do it first. If you want to try it on your own, you can pause it now, or you can wait and do it with me. So every term is divisible by 5, but because there's a negative on the first term, and notice that we go x squared, then x, then no x's. That's the way we order things, just like our standard form quadratics, ax squared plus bx plus c. So because there's a negative on the first term, I'm going to take a negative 5 out and not just the negative. And if I do that, I get x squared. And now I do 20x divided by negative 5 will be negative 4x. And now I do negative 15 divided by negative 5, which is positive 3. Okay, so that's what I was hoping for on this one. Now, as a bonus, you can actually factor this further. I haven't taught you that yet. That'll be the next lesson. Tomorrow probably. I'm thinking I'm going to post lessons Monday, Tuesday, Wednesday, and then that'll be it for the week. And then I'll post a new one the next Monday. So if you could do that one, great. Now I'm going to give you your sort of exit question before I leave you to it, and that's going to be negative 8x squared plus 20x minus 32. Okay. So I encourage you to pause right now and try to factor that. Pause now. And here I go. So the first thing I'm going to do, I've got a negative out front, so I'm going to take a negative out. Now I look for my greatest common factor. It's not 8. 8 doesn't go into 20. 4, though, 4 goes into everything. So if I take a negative 4 out here, negative 8x squared divided by negative 4, negative 8 divided by negative 4 is 2. X squared divided by no x is x squared. 20 divided by negative 4 is minus 5. X divided by no x is x. Negative divided by negative is positive. 32 divided by 4 is 8. Oh, little glitch there. Oh my goodness, why can't I draw an 8? Here we go, attempt number 3. Ah! That was even worse than the other ones. I will get an 8 here, I promise. Yeah, that's an 8 right there. And then this is supposed to be a bracket. Okay. So there's your very messy final exit question. All right, so that's about 25 minutes. Sorry, but this is on YouTube, so you can increase the playback speed if you want. Good luck, folks.